The mud pump is the heart of the drilling operation, providing constant circulation of drilling mud, essential to the cooling and lubrication of the drill bit, as well as flushing of the cuttings from the hole. Some abrasive and corrosive materials are always present in the circulating mud, resulting in extreme wear on the pump's fluid end parts. Replacing worn or damaged fluid end parts is not especially difficult, but the proper procedure should always be followed. This is very important because mud pumps are precisely engineered to very close tolerances. Therefore, improper replacement of parts will shorten the service life of the parts and could result in severe damage to the pump. Bear in mind that a multiplex pump moves fluids at a pressure, and in order to do this, two basic types of pressure seals must be maintained in the pump. One is the non-moving type of pressure seal, such as the metal-to-metal contact between the pump deck and the valve seat taper. The other type is a moving seal, in which a flexible material maintains a pressure seal by bridging a small clearance between two parts in the manner of an O-ring. This type of moving seal must be maintained by the piston rubber, valve inserts, liner packing, and gaskets. This presentation has been prepared to demonstrate the proper procedure for replacing fluid end parts in each basic type of multiplex mud pump. We'll start with the L head type. The procedure begins with replacement of the piston and liner. The first step is to disconnect the liner flushing and coolant lines. Next, you remove the splash shield and lay it out of the way. Next, loosen and remove the clamp that attaches the intermediate rod to the pony rod. After loosening the piston rod lock nut, separate the intermediate rod from the piston rod by unscrewing it. Never pry between the joint faces of the intermediate rod and the pony rod. These surfaces must be kept perfectly smooth and unmarred. Next, remove the rod and piston from the liner. Then, take off the liner retention clamps and remove the liner by hand from the power end of the pump. Immediately after removal of the liner, thoroughly wash out the pump to remove any remaining mud before it has a chance to dry and harden. This prompt action will simplify the task of installing the new liner. Before installing the new liner, be sure to remove the coating of rust preventative material from the ID. This coating serves only to protect the liner board during shipment and storage. It has no lubricating value and will damage the piston rubbers if it is not completely removed. Diesel oil or another suitable solvent should be used to remove the protective coating. The liner then should be wiped dry. Carefully examine the packing and guide areas on the liner to make sure they have not been damaged in shipment. Now, back to the pump. As we noted, make sure the sealing and guide surfaces into which the liner will fit are completely free of any foreign matter, such as rust, bayrite, or bits of rubber. Be especially careful not to leave any foreign matter on the face of the fluid cylinder. The line must have a metal-to-metal contact against this face. Any particle of matter caught between the two surfaces will prevent an effective seal and also cause the liner to cock. This would result in excessive wear to both the liner and the piston. Now, lightly grease the surfaces in the pump that will support the liner packing and liner. Use general purpose grease for this. Never make the mistake of trying to use pipe dope as a substitute for the general purpose grease. It won't work and can cause a lot of damage. Next, use a wire brush to thoroughly clean all corrosion and mud from the liner retention parts. Then lubricate the liner retention parts with general purpose grease. To complete the preparation of the new liner, lightly grease the guide and packing areas with general purpose grease. Also, lightly grease the liner packing and install it in the recess on the liner. Then, slide the liner carefully into place in the pump cylinder. Reinstall the liner retention assembly and tighten the liner securely against the cylinder. If there is a liner retention clamp, make sure that the two clamp faces do not come completely together when made up tight. There should always be a gap between the tightened clamp faces. If the gap is not there, some of the retention parts are worn and they should be replaced. As a final check, after tightening the liner against the cylinder face, reach through the liner and feel the packing with your fingers. This is done to make sure it hasn't fallen down. The next step is to prepare for the installation of a new piston. Begin by removing the old piston from the piston rod. Using a wire brush, thoroughly clean the end of the piston rod. Make sure you remove all foreign matter from the threaded area and from the radius and shoulder of the rod. After wire brushing, wipe the piston rod clean with a rag. Again, be especially careful to clean the radius and shoulder area where the O-ring must make a seal. Now, lightly lubricate the O-ring that comes with the new piston using general purpose or lithium-based grease. Install the O-ring in the groove in the piston. At the same time, spread the grease smoothly across the O-ring and the piston face. Lightly lubricate the radius and the shoulder area of the piston rod with the same grease. Make sure this is only a light coating. Too much grease here could result in a loosening of the piston on the rod after the pump is in operation. After placing the new piston on the rod, lubricate the threads of the rod and the piston nut liberally with a general purpose or lithium-based grease. By hand, screw the piston nut onto the piston rod until the locking material in the nut makes it impossible to turn it farther by hand. If you can hand turn the nut on the rod past the locking material, the nut is worn out and must be replaced. Now, tighten the piston nut by having a man weighing 175 pounds or more stand on the spline nut wrench. If the piston rod is 1.5 inches in diameter at the threaded end, the man should stand on the wrench at a point 36 inches from the piston nut. If the piston rod has a diameter of 1 inch at the threaded end, the man should stand on the wrench at a distance of only 18 inches from the piston nut. After tightening the nut, thoroughly lubricate the piston with general purpose grease. Also, thoroughly lubricate the bore of the liner with the same kind of grease. This is an important aid to the installation of the piston and also provides needed lubrication for startup of the pump. Carefully center the piston so it is centered in the bevel of the liner. To push the piston into the liner, use a piece of wood as a spacer between the piston rod and the pony rod. While one man holds the rod and spacer in position, another man turns the pump by hand until the piston is pushed in the liner. Then, turn the pump back and remove the spacer, clearing the way for installation of the intermediate rod. Inspect the mating faces and alignment pin of the rod components to make sure they are clean and smooth. It is important that the rod faces match up metal to metal and square to the center line of the rod. Next, lightly oil the tapered piston rod thread and screw the intermediate rod to the piston rod by hand. Then, lightly oil the clamping faces of the rod clamp and install it, but do not tighten the bolts at this point. Next, tighten the intermediate rod to the piston rod. This connection should be tightened with the force a man can exert on a 24-inch pipe wrench. Secure the connection by tightening the locking jam nut in the same manner and with the same force. Complete the connecting of the intermediate rod to the pony rod by tightening the rod clamp as recommended by the pump manufacturer. Be sure to bring the faces of the clamp up evenly. Also, make sure the clamp faces do not come completely together when tightened. Before reinstalling the splash shield, check and make certain the water jets are set for the size liner you are using. They should spray 5 to 7 gallons a minute per cylinder. The sizes are stenciled on the back side of the splash shield. Then reconnect the flush line and reinstall the splash shield. Having completed the replacement of both piston and liner, the next task is replacement of worn valves and valve seats. These are easily accessible on the L-head type pumps. The first step in the procedure is to remove the valve cover and lift out the valve spring and valve. To pull the valve seat, it is best to use a J-tool and hydraulic jack. Begin by placing the hooks of the J-tool head completely around the cross arms of the valve seat. Then, turn the threaded main stem into the J-tool head to pull the hooks up tight against the bottom of the cross arms. Place the hydraulic jack over the main stem so it rests on the split puller block provided with it. Install the C washer and the nut on the stem above the jack. Release the hydraulic fluid return valve to compress the puller and tighten the nut as tight as you can get it. Before using the jack, install a safety chain around the puller assembly as a safety precaution. This prevents the possibility of the jack jumping off the pump and causing injury or damage. Now, pump up the hydraulic jack until the puller dislodges the valve seat. After removing the puller assembly and dislodged valve seat, immediately wash out the pot area. This will get rid of any remaining mud before it has a chance to dry and harden on the pump deck and taper area. Since the new valve seat must have a complete metal-to-metal contact against the taper surface, it is very important to clean the taper and pump deck surfaces thoroughly before installing the new seat. Use emery paper to remove any accumulation of mud or rust, rubbing with a circular motion. If the pump has a shoulder built in at the bottom of the taper, be sure you clean it carefully. Any foreign matter left on this shelf would prevent a proper seal between the seat and taper. After smoothing off any accumulations of foreign matter with emery paper, use a solvent to completely clean the taper surface. Then thoroughly dry the area to permit a metal-to-metal contact. To prevent the possibility of any corrosive fluid leaking onto the cleaned and dried taper surface, Use a cloth to build a temporary dam where the ports open into the pot area.